Today we're going over chapter 22, compare and two proportions. If we want to compare two populations or compare the responses to two treatments from independent samples, we look at a two-sample proportion. The null hypothesis is there is no difference between the two parameters. The null hypothesis could be P1 equals P2 or P1 minus P2 equals 0, where P1 is the true proportion in population 1 and P2 is the true proportion in population 2. For our alternative hypothesis, we would have one of the following, with P1 being greater than P2 or P1 minus P2 being greater than 0. That's one-sided. Or P1 is less than P2 or P1 minus P2 is less than 0, which is also one-sided. Or you'd have P1 not equal to P2 or P1 minus P2 is not equal to 0, which is the two-sided one. With these, if you're using a difference in the null hypothesis, you want to use a difference in the alternative hypothesis. Before you begin, you need to check your assumptions. When discussing our assumptions, N1 is the size of sample 1, N2 is the size of sample 2, P hat 1 is the proportion in sample 1, and P hat 2 is the proportion in sample 2. For our assumptions, we need to have random samples. Both samples should be chosen independently of each other. Our population is greater than or equal to 10N for both samples, so that's your 10% condition. And then N1 P hat 1, N1 Q hat 1, N2 P hat 2, N2 Q hat 2 should be greater than or equal to 10 for the confidence interval and the hypothesis test. And when we talk about a pooled proportion, P hat, it's the total successes for sample 1 plus the total successes for sample 2 over the total of those in sample 1 and sample 2. If the above assumptions hold, then the difference in sample proportions is an unbiased estimator of the difference in population proportions, and the mean of the sample and distribution of P hat 1 minus P hat 2 is equal to P1 minus P2. The variance of P hat 1 minus P hat 2 is the sum of the variances of P hat 1 and P hat 2, which is P1 Q1 all divided by N1 plus P2 Q2 all divided by N2. Thus, the standard deviation of the sample and distribution would be the square root of P1 Q1 all over N1 plus P2 Q2 all over N2. And a lot of times you'll see hat with these, not just P1 Q1. So you could see P hat 1, Q hat 1, P hat 2, Q hat 2. For the confidence interval, the standard error is the square root of P hat 1, Q hat 1 all over N1 plus P hat 2, Q hat 2 all over N2. And the confidence interval is P hat 1 minus P hat 2 plus or minus Z star times the square root of P hat 1, Q hat 1 all over N1 plus P hat 2, Q hat 2 all over N2. This is called the two proportion Z interval. For the hypothesis test, because we initially assume the null hypothesis is true, P1 equals P2, which implies both samples are from the same population, therefore our best estimate of the true proportion is the pooled value of P hat. Thus, the standard error becomes the square root of P hat Q hat times 1 over N1 plus 1 over N2. In order to standardize P hat 1 minus P hat 2, subtract the mean and divide by the standard error. So our Z would be p hat 1 minus p hat 2 minus p1 minus p2, which is usually always 0, all over the square root of p hat q hat times 1 over n1 plus 1 over n2. And you must write this formula out every time that you use it, same with the confidence interval formula. This is the test statistic used to carry out the significance test to proportion z-test.